Hi, Mr. Richards here. Today's lesson is on triangles. Our first concept is the angle sum of a triangle, and quite simply, the sum of the measures of the interior angles of a triangle is 180 degrees. And so we can use that to help us find missing angles in triangles. So we would like to find the measure of angle F in triangle DEF. So we know that the measure of angle D plus the measure of angle E plus the measure of angle F are going to add up to be 180 degrees. Well, D is 100. E is 33, F is our unknown, so X, and that's going to add up to be 180 degrees. We can combine 100 with the 33 to be 133, plus X equals 180 degrees. And if we subtract to solve this equation, the 133 from both sides, we can get X equals 47 degrees. So, the measure of angle F is equal to 47 degrees. In our next type of example, we can find missing angles using ratios. So the measures of the angles of triangle WYZ are in the ratio 2 to 3 to 5. What are the measures of the angles? Well, what if we say that our first angle, which would be angle W, what if we say that that's going to be equal to, well, 2x for the 2? Then what if we say the measure, or the angle Y is going to equal 3x? And then angle Z is going to equal 5x. Well, in this case then, 2x plus 3x plus 5x would have to equal 180 degrees. And if I add the 2x, 3x, and 5x, my result would be 10x equals 180 degrees. And to solve the equation, if I divide by 10 on both sides, x is going to equal 18 degrees. Well, that's what my x equals. But what about the actual angles? Well, if I take this x equals 18 and put the 18 back in for each of my x's, I could find these angle measures. So I would have 2 times 18 equals 36 degrees. Well, then I would have 3 times 18 equals 54 degrees. And then I would have 5 times 18 equals 90 degrees. And so, to list out my answer, the measure of angle W equals 36 degrees. The measure of angle Y equals 54 degrees. And the measure of angle Z is equal to 90 degrees. So given a 2, 3, 5 ratio, I can say 2x plus 3x plus 5x equals 180. Solve for x, but be sure to put this value back in for each of your angles to find the measures of the angles. In our third example, in the figure below, the measure of angle 4 is equal to 135 degrees. Find the measure of angle 2. Well, we might as well label this angle 4 as 135 degrees. And we're looking for the measure of angle 2. Well, we can't get there directly. So what we're going to need to use are supplementary angles first, because we can look here and we know that the measure of angle 1 plus the measure of angle 4 is going to be 180 degrees. And so if I just call my one x, I can say x plus the 135 for the measure of angle 4 is going to be 180. And if I subtract 135 from both sides to solve this equation, my result is going to be x is equal to 45 degrees. Next, now that I know that this x is 45 degrees, I know 2 of the 3 angles of this triangle. I know that the measure of angle 1 plus the measure of angle k plus the measure of angle 2 are going to be 180 degrees, since the interior angles of a triangle add up to be 180 degrees. And now I can substitute. 45 is my measure of angle 1. The measure of angle k, well, that is labeled as a right angle here, which means 90 degrees. Plus the measure of angle 2 is unknown, so we could just, call it y if we wanted to, plus y equals 180 degrees. If I combine my 45 with 90, it's 135 plus y equals 180. And then subtract the 135 from both sides to solve the equation. And y is going to equal 45 degrees. And so the measure of angle 2 is equal to 45 degrees. In our last set of examples, we get to classify triangles. And so we can do this by angles and sides. Now, if we have one right angle, this is going to be a right triangle. And so we would have something that looks like this, where we have the one right angle. An obtuse triangle has one obtuse angle, an angle that's larger than 90 degrees. And that's an obtuse angle. And so, there you go. An acute triangle has all acute angles. So something that looks a little bit like that. All the angles are acute, all less than 90. And then we get to scalene isosceles and equilateral triangles, triangles that are classified by their sides. And a scalene triangle is a triangle that has 0 equal sides. An isosceles triangle has 2 equal sides. And an equilateral triangle has 3 equal sides. Now, as for our isosceles, the way we can tell sometimes, and the way these will be marked, is that if I see these 2 dashes, that means these 2 sides are equal to each other, so it's an isosceles triangle. Or sometimes if you see 3 dashes, that means we have the 3 equal sides, so it's an equilateral triangle. Scalene, you really won't see any dashes, and there won't be any equal sides. So if we need to classify each triangle by its angles and sides, I will first look by its angles. Are there any right angles here? No. Are there any obtuse angles? Yes. So I can say, all right, this is obtuse. Are there any equal sides? No, so this is an obtuse scalene triangle. What about B? Do I have any right angles? Yes. So this is going to be a right triangle. What about sides? Well, I have two equal sides, which means it is an isosceles. It's a right isosceles triangle. And that is it for this lesson on triangles. Good luck.